The first thing we'll figure out today is the natural frequency at which an object vibrates, or the speed of wave of a guitar string. The first thing you need to know is that this quantity is determined by the tension of the string, the linear density, and the length of the string. Our group didn't have the appropriate material to figure out this number, so instead we made them up. So the relationship between these three can be shown in the following equation. The speed of the wave is equal to the square root of the tension of the guitar string divided by the mass times the length of the guitar string. And here are the numbers: 250 for the tension, mass 0.765, and for the length is equal to 0.57 meters. This is after I multiply these two together, I got the following number, which is 0.4365. Afterwards, I divided that number by 250, and it gave me the following number: 581. Afterwards, I took the square root of 581, and I got the following number, which is 23.94. The following number is the speed of the wave. After that, we'll figure out how to determine the wavelength of with the following equation. The wavelength is equal to 2 times the length of the guitar. After we multiply the length of my guitar times 2, we got the following number, which is 1.53 meters. And now that we know what the wavelength is, we can now finally determine the frequency of the wave with the following equation. Speed is equal to frequency times wavelength. We already calculated what the speed was, which was 23.944, equal to the frequency. The frequency is the variable we want to isolate in order to figure out what the number is. We already calculated the wavelength, right? The wavelength was 1.53. In order to isolate the f, we have to divide by 1.53. You know the math we've done all these years. And 1.53 cancels out, and then f is equal to this number right here. We divided it and we got this number. The frequency of the guitar string is 15.640 hertz. I want you to know that the speed of sound is highly affected by the temperature of the air. We can determine the speed of sound through the air with the following equation. V, which is velocity, is equal to 331 meters per second plus 0.6 meters per second, which is in parentheses, and you know what that means, multiplication, blah 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 blah, times temperature. Temperature, we put the 15 because that's pretty much like the average in Celsius that we've had throughout these couple of months. So afterwards, we figured out the equation. You know, we followed the pattern for orders of operation, and we got the number 440 for our velocity in air, or the temperature, which was 15 degrees Celsius.